Today we are going to discuss some important points on acids, bases and salts. So now usually you observe in nature any compound, any compound. So it may be a acid or it may be a base or it may be a salt. Okay. Now how we will test these acids, bases and salt? So what are the chemical reactions involved in between these? That we will see. Now just to see, acid plus base is you will get a salt plus water. This is the very important reaction occurs between acid and base. So this is also called neutralization reaction. Neutralization reaction. Okay, they may ask questions on this. Okay. Now how we will test this acid? Okay, this can be tested by using litmus paper. Litmus paper. Both acids and bases you can test by using litmus paper. So they may ask questions on this litmus paper also. This is also important and litmus paper also important, and neutralization reaction, that is also important, and the salt and water, whatever products you are getting, that is also important. They may ask one more questions on this. Okay. Now acids, again they are divided into strong acids, and weak acids. Okay. Now what are all strong acids? So chemical formula for strong acids: HCl, HNO3 and H2SO4. So these are also called inorganic acids. Inorganic acids. Just you see here, all are having hydrogen as a common element. So why these acids are called inorganic acids? Because they are not decomposing or degrading. That's why they have called it as a inorganic acids. Now what are weak acids? Weak acids usually called organic acids. Organic acids. So example: citric acid, tartaric acid, etc. These are all organic acids. They are decomposable or they will degrade. Okay. Now what are the properties of these acids? Okay, here again it is divided into two properties. One is physical property and the other one is chemical property. property. Now what are physical properties? Now again we have to discuss on chemical properties. So acids, they will turn blue litmus to red. So here acids turn blue litmus to red. So they may ask questions on this. Okay. So they are having sour taste. Sour taste. So they may ask questions on this also. Okay. And they will conduct electricity. Electricity. Why? Because they are having common hydrogen. That's why this hydrogen conducts electricity in solution form. That means if it is in aqueous, then these acids conducts electricity. That is also very important. They may ask questions on this. Okay, and fourth one, their pH is 1 to 7. Okay, so last point, they generate H plus ions. They generate H plus ions. These ions only these H plus ions only responsible for conductivity of electricity in aqueous solution. So these are all the important physical properties. All are very important. They may ask in exam. Now we will discuss some chemical properties on acids. Okay. So number one. Acids reacts with metal. What you will get? This is also important question. They may ask in exam. So acid plus metal, you will get a metal chloride plus hydrogen gas. This is general example. Now if you put hydrochloric acid into zinc granules, you will get ZnCl2. See, here it is 2 is there. You have to put 2 here plus H2. So equation is balanced. This is also, see, liberation of hydrogen gas. They may ask questions on this. Okay. So next is metal carbonates. Metal carbonates. See, carbonates means you have to remember that it is CO3. Suppose if you see CO3 in a reactant, so you can tell that product there may be a possibility of liberation of carbon dioxide. So they may ask questions on this also. I think you understood. Metal carbonates. Carbonates means CO3, and one more thing is there, HCO3. That we will discuss in next. CO3. Suppose if you are having a reactants, in one reactant if you see the carbonate, then there may be a possibility of liberation of carbon dioxide in products. That is very, very important. Okay. Now we will see the example. So that is second example. See, metal carbonate, that is sodium carbonate. plus HCl. So you will get NaCl plus H2O plus CO2. See, liberation of carbon dioxide. You see here carbonate is there. That's why you got a liberation of carbon dioxide gas. So this is gas, this is liquid, this is aqueous. So this is also aqueous, this is solid. See, whenever if you see the carbonate, they may ask question on this. Okay, whenever you see the carbonate in the reactant, you imagine that there should be a liberation of carbon dioxide in the product side. Okay, now balancing, you see H2 is there, so you have to put 2 here. Okay, I think all balanced. Now this is the reaction between acid and a metal carbonate. This is a metal and carbonate. Okay, sodium is a metal and carbonate, metal carbonate. They very important, they may ask questions on this equation. They will expect that liberation of carbon dioxide in the product side. So number third we will see. With metal hydrogen carbonates. With metal hydrogen carbonates. See, they are telling hydrogen carbonates. That means one metal is there, one hydrogen carbonate. See, whenever you see the hydrogen carbonate, again you imagine there may be a liberation of carbon dioxide in product side. Very important, they may ask questions on this also. Okay, now again same NaHCO3 plus HCl, you will get NaCl plus H2O plus CO2. See, again CO2 liberation. Okay, here it is 2 is there again. No, here it is balanced, I think. Here one more 2 is there. So almost equation is balanced. HCl is aqueous. These physical states you have to mention. Okay, then NaCl again, it's aqueous. This is liquid. Carbon dioxide is gas. So this is a solid. Okay, now you see both the cases here, you see carbon dioxide, releasing carbon dioxide in both the cases. That means metal carbonates and metal bicarbonates. If you pass this carbon dioxide to CaOH twice, calcium hydroxide. If you pass this carbon dioxide to the calcium hydroxide, this is called lime water. So this is very important reaction. They may ask questions on this. So you will get CaCO3. This is white precipitate, white PPT. If you put water to it, no, plus liberation of water. This is wrong. So carbon dioxide plus water you will get. Carbon calcium carbonate is a white precipitate. Okay. Now again we will see. See, this is also very important, calcium carbonate. So where you will see this calcium carbonate? Calcium carbonate is nothing but the chemical composition of limestone is calcium carbonate, chalk, calcium carbonate, marble, calcium carbonate, okay, and egg shells, calcium carbonate. See, they may ask questions on this. Egg shells, if you put HCl, what you will get, like that they will ask. So this is also very important reaction. Now we have passed carbon dioxide to lime water, that is calcium hydroxide. What we got? Calcium carbonate, that is white PPT plus water. Now if you pass carbon dioxide excess to CaCO3, okay, whatever here reaction you see, same reaction you take, plus water, you are passing excess carbon dioxide to calcium carbonate and water. What you will get? You will get calcium hydrogen carbonate, calcium hydrogen carbonate. See how you are getting calcium carbonate and calcium bicarbonate. Calcium carbonate we are getting because of combination of calcium hydroxide plus carbon dioxide. If you pass excess carbon dioxide to calcium carbonate plus water, you will get a bicarbonate of calcium. So this is also very important, they may ask in examination. So next we will see with metallic oxides. With metallic oxides, what you will get? See, metallic oxide, that means Cu oxide plus 2HCl. So you will get CuCl2 plus H2. Just you see this, this is a salt, this is water. So that means this is basic in nature, this is acid. Now you see, base plus acid, you will get salt and water. It is very beautiful. Okay, this CuCl2 is there, no? That is blue green color, blue green color. So they may ask questions on this. Okay, now see what you will see, base, that means metallic oxides plus acid, you will get a salt plus water. Okay, then you know that metallic oxides are basic in nature. So now, so this is fourth one. Now fifth one we will see. So with water, what you will get? With water, what you will get? HCl plus H2O, you will get H3O plus. This is hydronium ion plus Cl minus. Okay, so this is only responsible for generation of hydrogen ion. Generation of hydrogen ion. How it has formed? How it has formed means H3O plus H2O, water, plus H plus ion is equal to H3O plus. This is hydronium ion. So this is also very important for the point of examination, and due to this formation of hydrogen ion, acids conducts electricity. This is also very important. Now we will see some pH scale. pH scale, how it is? It is one scale. They have mentioned a numbers 0, 1, 7 and 14. See, this is also very important. They may ask in questions. How they will ask? See, up to 7 pH from 1 to 7 is called acids. 7 is neutral, and this is bases from 7 to 14. So here our gastric juice is there, no? So it is a pH of 1. Gastric juice, that is pH 1. They may ask questions on this gastric juice. So number 7, it is a pure water, that is neutral, pure water. And number 2, it is lemon. Okay, they may ask questions on this. Pure water is having pH of, like that they will ask. And 11, it is ammonia, NH3. And 14, it is sodium hydroxide, CaOH. It is sodium hydroxide solution. Okay, they may ask mainly this part, gastric juice or lemon or pure water. Few cases they may ask sodium hydroxide and ammonia. Maximum as per our records they have asked this portion. Question papers I have seen, they have asked gastric juice, pure water. Lemon very few case. Okay, so that means you have to remember this pH scale, how it is marked from 0 to 14. In that pH 1 is gastric juice and 2 is lemon, 7 is pure water. So 14 it is sodium hydroxide. This is also very, very important. So this you have to keep it in mind. Okay. Now we will see some important points on bases. Again, these bases are divided into two types: strong bases and weak bases. weak bases. So strong bases are they are completely ionized in water, gives OH minus ions. So that is NaOH, KOH, etc. So what is the nature of this? If you dissolve strong bases in water, in water, you will get a OH minus ion. Again, OH minus is responsible for conducting electricity. So these ions are responsible for conducting. Now you see what is the common between acids and bases. See, both are ionized and both are conducting water at aqueous solutions. That is very, very important. Both will conduct electricity in aqueous media. That is also very, very important. That you have to mention it. Okay. Now weak bases are partially ionized in water. So these are all partially ionized in water. So example, ammonium hydroxide, magnesium hydroxide, MgOH twice. Okay, now see bases, we will discuss few more points. Bases, again you have to see that physical properties and chemical properties. Physical properties and chemical properties. Okay, now again physical properties. So it is litmus paper turns red to blue. Litmus paper turns red to blue. So they may ask questions on this. So they are bitter in taste. Bitter in taste, generates OH minus ions in water, aqueous medium. So their pH is greater than 7. So they conduct electricity. So this is also very important point. Now we will come to chemical properties. Now again we will see with metal. With metal, what you will get? So see, zinc plus NaOH. So you will get Na2Zn O2 plus H2. This is sodium zincate. So liberation of hydrogen gas. Next we will see. Next, with non-metallic oxides. With non-metallic oxides. So calcium hydroxide plus CO2. You will get a CaCO3. This is a white PPT. Previous questions points we have seen. There we have seen plus water. So it is a liquid and it is a white precipitate solid. Okay. Gas, aqueous. So this is also important reaction. So next, what you will get with water? So NaOH in presence of water. So this is a solid. What you will get? You will get Na plus aqueous plus OH minus aqueous. So these ions are responsible for conductivity of electric current. Okay. So in presence of aqueous media, NaOH generates OH minus ions. So important point, bases which are soluble in water. Bases which are soluble in water are called alkalis. They are called alkalis. They may ask questions on alkalis. Okay. Now some important points again we will discuss on indicators. Indicators again it is of two types. One is natural indicators and synthetic indicators. Synthetic indicators. So natural indicators means what? We got these indicators by natural sources. So example, litmus paper. Okay. So this is enough I think for you. And synthetic indicators are phenolphthalein. Example, just you see the spelling. Phenolphthalein indicator. And methyl orange, one more is there, methyl orange. So these are artificially we have made. So we have produced these indicators in a laboratory. Methyl orange, I will write. Methyl orange. Now again we will discuss. So litmus, if it turns red to blue, if it is red, it is acidic. If it is blue, it is a media is basic. Methyl orange, you see, methyl orange. In acidic media, it is a pinkish red, and in basic media, it is a yellow. Phenolphthalein. Phenolphthalein. So it is colorless in acidic media. Colorless in acidic media, pink in basic media. Pink in basic media. See, apart from these, one more indicator is there, that is special indicator, olfactory indicator. Olfactory indicators. So what are these? These indicators whose odor changes in acidic or basic. So example, onion. Smell of onion. Okay. So smell. So onion smell changes if the media changes from acidic to basic, basic to acidic. So these are all called olfactory indicators. They may ask questions on this also. Okay, now till now what we have seen? Acids plus bases plus indicators. Now only left salts. Now we will discuss some important points on salts. Salts are neutralized reaction. Salts are obtained by neutralization of acids and bases. That means acid plus base, you got salt plus water. So this reaction is called neutralization. Neutralization reaction. That's why salts are electrically neutral. Salts are electrically neutral. Okay, some examples we will see. Already we have seen. Once again we will see HCl plus NaOH. You will get NaCl plus H2. This is liquid, this is aqueous, and this is solid. Okay. Now important salts we will discuss. So what are all important salts? One is sodium chloride, sodium hydroxide, calcium oxychloride, CaOCl2, sodium bicarbonate, NaHCO3, sodium hydrogen carbonate, sodium carbonate decahydrate, sodium carbonate, deca means 10, decahydrate. So last one, calcium phosphate hemihydrate, calcium sulfate hemihydrate. Hemi means half. Hydrate. So formula we will see. See, sodium chloride is nothing but common salt. It is common salt what we are using in our kitchen. So that chemical formula for this is NaCl. Also it is known as common salt. Okay. So NaOH, sodium hydroxide, it is commonly called caustic soda. Caustic soda. See, these questions they may ask in examination. They will ask, write a chemical formula for caustic soda. So that's why you have to thorough full sentences. Okay. So calcium oxychloride, that is called bleaching powder. Bleaching powder. So they may ask questions on this also. So next, sodium hydrogen carbonate. This is called baking soda. Baking soda. Now sodium carbonate decahydrate, that is called washing soda. Washing soda. So calcium phosphate hemihydrate, that is called plaster of Paris. Plaster of Paris. See, these questions are very, very important. They may ask in examination. Okay. Now, see, up to here we have seen the chemical formulas. Okay, now sodium carbonate or washing soda. So for this it is Na2CO3. Deca means 10H2O. So plaster of Paris, it is a calcium sulfate of H2. See, these are all very important chemical formulas. You have to remember all this. Now we will see how we are going to manufacture NaCl, NaOH, CaOCl2, NaHCO3, Na2CO3, 10H2O and plaster of Paris. Okay, now first one we will see how we are preparing NaCl. So these reactions are very important. So NaCl we are preparing acid base from acid base reaction. So NaOH plus HCl. So we will get NaCl plus H2O. See, we got NaCl. So both are aqueous. This is also aqueous. 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 So we got NaCl. Now, where we are using this aqueous? Where we are using? So a raw material, it is number one is we are using in kitchen as a common salt. Okay. So next, it is a raw material for making sodium hydroxide. sodium hydroxide, baking soda, okay, washing soda, and bleaching powder. So this NaCl is a raw material to make sodium hydroxide, baking soda, washing soda and bleaching powder. Okay, now this one we discussed. Number 2 we will discuss. So that is NaOH. NaOH, how we are preparing. So NaOH, how we are preparing. See, here we have told. So NaCl is a raw material for making NaOH. See, here it is there. That means NaCl we have taken as a one reactant. NaCl plus H2. Okay. So we got chlorine is there. That means liberation of chlorine plus liberation of hydrogen. See, these are all again important. So chlorine, it is used for disinfection. This is used for fuel. Okay, now we go to balancing part. 2 NaCl, 2 H2O, 2 NaOH, Cl2, H2. This is gas, this is gas, this is aqueous. So this is aqueous and this is also aqueous. Aqueous means this is liquid. Okay, see, chlorine, this is very very important. They may ask in questions, examination. So it is used as a disinfectant. So hydrogen is used for fuels. Okay, then this NaOH where we are using soaps and detergents. Okay, next, paper making. So bleaching powder, bleaching. So I think these three are enough, I think. Okay, now see, we are using it for bleaching powder. Okay, now 3, that is bleaching powder, CaOCl2. How we are preparing? Take this Cl2. So you will get what you will get, CaOCl2. We want CaCl2, that's why we have taken this Cl2. Plus we want calcium, CaOH twice. So we will get calcium oxychloride plus water. Okay, so this is oxidizing agent. Then where we are using calcium oxychloride. So it is a bleaching powder, hence it is used for washing clothes. Washing clothes or laundry, we can tell. And disinfectant, on in water. So this is also very important. They may ask in examination. So as already we told, it is used as a oxidizing agent. Oxidizing agent. So fourth, we will see baking soda. That means NaHCO3. So what we got? What we have to get? NaHCO3. So that means we have to use NaCl as a raw material from the first reaction, plus ammonia plus carbon dioxide plus water. So you will get ammonium chloride. Okay. So where we are using this? It is used in making baking powder, and it is used as a antacid. So they may ask these questions. See, whenever carbonate you observed, so just you can mention that it is fire extinguisher. So why fire extinguisher? Because it eliminates carbon dioxide. Okay, so this carbon dioxide is responsible for fire extinguisher. Okay. So next, fifth, it is washing soda. That means Na2CO3 10H2O. So we are getting Na2CO3 10H2O. So sodium carbonate plus 10H2O. Straight away you will get the washing soda. So washing soda, where we are using? Again, it is used in soaps, paper and pulp technology, pulp and paper industries, and also it is used as a cleaning agent. And also it is used as a softening of hard water. So this may ask in examination. So next, last one, it is a plaster of Paris. So that is CaSO4 of H2. See how we are manufacturing this. So this is manufacturing by heating of CaSO4 to H2O is equal to CaSO4. This we have to heat it. You will get half H2O plus 1/2 H2O going out. Okay. So this you have to heat at 373 degree Kelvin. Okay, next this washing soda, this is called recrystallization of sodium carbonate. Okay. So next, baking soda. So it is cold concentrated sodium chloride. This is cold concentrated sodium chloride, and also it is called brine. This is also very important. They may ask in examination. Write the chemical formula for brine, like that they will ask. Okay. So next, calcium oxychloride. It is passing chlorine gas over dry slaked lime. So chlorine gas we are passing to dry slaked lime. This is called slaked lime. So this they may ask in examiner. Write the chemical formula for slaked lime. So this they may ask. So for this caustic soda, what you have to do? Electricity you have to pass through the aqueous solution of sodium chloride. So this is aqueous solution. For this you have to pass the electricity. This is also called chlor-alkali process. Chlor-alkali process. This is also important. Okay. So first one, it is combination of acid and base. See, all these uses, preparation, how we are preparing, all are very, very important. You have to concentrate on this. So you will get a whatever you are guessing, that you will achieve in your examination.